All right, let me show you this one, the two-time pad C105. I found out about this in this book by Howard Bloom. So first, let's talk about the one-time pad. The one-time pad is the perfect cipher. It is completely unbreakable. It's been known for centuries. What you have to have is a key string, which should be random. I'm using a readable sentence here, though, but and just pages of this random stuff. And you encrypt letters one by one using key letters. And you could use any cipher, like just the Caesar cipher, where you move it forward a number of spaces in the alphabet determined by this letter. The point is, every character in the key is used to encode only one character of the output, and no part of the key is ever used again. You cross out the lines you use and you use new lines. So there is no mathematical pattern at all. And the answer is you have to change each one of these letters into a different letter with no pattern at all. So there's no possible way to decrypt it without knowledge of the key. In fact, if you did a brute force attack on ciphertext, you would turn it into all possible text, including all possible readable text, and you'd have no way to know which one was right. So it's perfect and uncrackable. The only problem is you have a serious key distribution problem. You have to somehow securely deliver enough keys to the recipient that they never have to reuse any part of the key. So that turns out to be enormously difficult. So this is almost never used for that reason. So let's implement it in Python. Here's a Python script that does it. This is the one-time pad. So I'm gonna, and now you folks know some Python, so this should be relatively clear. So let's call this one.py and put it here. All right, so I define a key and plain text. So the key is unbreakable, awesome, secret, secure system, and the plain text is 7. And so all I do is, for every letter in the plain text, I turn it into its index, which is the ASCII value with ORD. Then I take the same thing for the key, and then I use XOR in this case. I XOR the plain text with the key as bytes. That's just a way to combine the plain text byte with the key byte, and then I add that to the ciphertext. So let's run this one and see how it looks. Python 3, 1.py. All right, so here it is encrypting byte by byte. This is F and that's U, so it's 46 and 55. You XOR it, you get 13, and so on. So here's the encrypted stuff. It's unprintable hexadecimal ciphertext. Most of these are unprintable characters, and that's your encrypted message. All right. Now, if you want to decrypt it, I just need to perform the same operation again, because it's XOR I used, and XOR undoes itself. So the only trick is I have to insert, let me do one decrypt.py. The only trick is I now have to take that hexadecimal stuff. And so this is how you turn hex into bytes. You use bytes.from hex, and that'll turn this into bytes. And then I can just perform the same operation, take a character in the ciphertext and a character from the key and XOR them together. So this should decrypt it. And so it turns back into 7. You can see it XORs it and slowly types out the answer here. So that's encryption and decryption with a one-time pad. And there's a challenge here, so you can do a couple of them. And then we can talk about the crib drag attack, which is pretty awesome. So what's going on here, if you use the same key twice, this perfect system shatters like glass and becomes incredibly unsafe for a simple reason. So if I have two ciphertexts that were encrypted with the same key and I don't know the key, I just guess at the key. If I can get any part of it right, like a word "the," if the key, for example, in my case, consists of readable English, then I just guess that there's a "the" somewhere. If it starts with "the," then I just decrypt it with that and see if any of this looks readable. And it looks like this is the start of the word "maybe never," and this is "you," so the next character is probably a space. So this is called a crib drag. You guess part of it, then you guess from the plain text revealed another couple of characters and try it again and just go back and forth. And even without a computer, you can quickly decrypt it. This is a fatal flaw. And so you can do it here, and you can do it by feeding in the key manually, or you can use a script. Here's a script that will let you do an interactive technique, which is a useful thing for here. Let me set this up. Just take me a minute. This is going to be crib.py. All right, so key. I'm only going to do the key, not the encrypted part here, but this will give you the idea. So I have the, and then some of these. I fill in dots where I don't know the key, then while, true. AEY colon space. Then I give spaces here to refer to it. Then print. This is also indebted. A char equals int of input of okay, and then val. Okay, now I'm going to insert that in the string. Key is key. I wanted to change one character in this key. So it's going to be key starting at 0 up to the one before the character you chose, and then the value you chose, and then the remaining part of the key, which starts from character +1 to the end. If I've done all that right, this will let us interactively change that key. So Python 3 crib. Okay, if THE, if I wanted to change the third space to a space, I would put 3 and then space. And now the key has a space in it. So this is how you can guess a character and fill it in. And all you have to do is add the XOR part to this, which you can see in the previous example. And you can choose which of these to guess and work back and forth and automate the crib drag attack, or at least make it interactive. And it turns out to be pretty cool. You can crack this first one pretty easily. The next one is more challenging just because it's longer and the key is longer. Here's an even longer one, but it's good, clean fun, and you might want to try that.